Hey, welcome to the Dev Days conference. You are in Hall 1 Languages and Frameworks with our speaker, Yoni. And the topic that he's going to bring us today is back into Frontend without the duct tape. Now, can you imagine this? Almost everybody who's been doing some development knows the amount of duct tape that comes with it. I'm a .NET C# developer. I use Visual Studio, and the amount of duct tape code, which boilerplate code, which keeps coming with it is so much. And what I actually hate is when I want to change something, I'm so afraid to get in there because if I change something, I don't know what's going to happen. And today, Yoni has something to share with us. And I'm actually very interested to understand how the whole thing works. So, Yoni, the stage is yours.
Thank you. Hi, everybody. Let's start. I'll start by saying this is a live coding session. I'll be running out of these slides in a few minutes. And from there on, it's all going to be me coding and you watching. So wish me luck, and I hope you enjoy. A few words about myself. I spend most of my time writing code. My focus has always been large, complex enterprise applications. I've been modernizing legacy applications, which usually have hundreds of database tables, hundreds of business entities, very complex user interactions, lots of CRUD, lots of complex workflows. So this is kind of my background. I'm both a lazy and an error-prone developer, which I say to make you understand that I need a lot of tools to help me, languages and tools that I both take and create for myself that have helped me work less, write less code, and avoid errors. But when I say less code, I don't mean any low-code tools or anything like that. I love code. I code all the time, and I just need tools to help me write less. I always prioritize getting features into the hands of users over beautiful architecture or bleeding edge tools. So that's something else you want to know about me. This is an image of my, I would say, best project to date. And this is a little bit about myself. So how I build applications is really traditional and simple. I like keeping things simple. 9 out of 10 times, it's going to be as simple as a single page application, using any framework you can imagine, like React, Angular, Vue, etc. An API server, usually Node.js, and that server interacts directly with a relational database. So most of the times, no complex microservice architectures, just a simple monolith that does the work. I really like keeping it simple. So I made a kind of a short list of the main features that I find in almost every CRUD application, applications that do a lot of CRUD. If I split it between my Node.js API server and my front end, it starts with model types. We need model types to move data around in our server, but we also need those model types on the front end and to interact with our UI widgets. We need CRUD API routes, get, put, post, delete to do all those interactions with your API server. And we also need to call those API routes from the front end, each and every one probably. We need data validation on the back end because we can't accept any unverified or validated data into our database. But we also need data validation on the front end to get our user's experience better and enjoy the power of the browser and making validations before we even call the API server. We obviously need access control because not every user is allowed to perform in every action. Some are limited, and we have to protect our API in our database. But what's interesting is a lot of the times we also need these rules to be reflected in our users' screens and interfaces, because if they're not allowed to perform an operation, this usually means they can't either see a button or use a button, or it's disabled. So there's authorization queues on the front end as well. And then there are other things going around in your backend, such as SQL calls or using an ORM. Paging, sorting, and filtering is almost always necessary. Real-time is sometimes required in a nice addition. And on the front end, you'll have your routes and your components. Now, looking at this short list, it's easy to see there are things in the front end and the API server which are basically a reflection of one another, right? We like to talk about a plug in a socket, because if we change the model types on the back end, this usually reflects a change in model types on the front end, as well as these API calls and routes that we build on the back end. And that can cause us a lot of mistakes and errors if we change one and not the other. So these are kind of reflecting one another. Same goes for data validation and access control. And on the back end, we see a lot of repetitive and boilerplate code. We were talking about that. Writing those same API routes, basically doing the same for one business entity or database table or another, and then you have your ORM or SQL calls, paging, sorting, and filtering. All of these tend to repeat. And boilerplate code is something that I really hate having and seeing and maintaining, especially maintaining, because then I want to change something and I have to go all over my code and look for what to change. Some modern full stack frameworks are starting to work on at least some part of this code duplication. If we're looking at model types and CRUD API routes, then we've been seeing a lot of advances in frameworks. These are frameworks in the React world. Obviously, there are others for other front-end frameworks. But if you look at Next.js and what they're doing today, if you look at Remix, they're making API calls and consuming those APIs a lot more holistic, and also sharing of model types between front-end and back-end. If you look at Redwood.js, which does that with GraphQL, or TRPC and T3, all are very interesting frameworks and tools that I recommend you take a look at, which make this whole thing more easier to work with, faster to develop, and less, it causes less bugs and errors. But for me, as I develop, I like to think of this whole thing. I like to think in a level that every single part of this list can be derived from a single source of truth. If I look at a business entity, I want to imagine or envision a way in which this entity can declaratively state all these things, such as what is the model type, what are the validations for the fields, what's the access control rules, and have that affect my entire application without writing a lot of repetitive boilerplate code. And so to make our lives easier as developers, I teamed up with a lifelong friend and colleague, and we created Remote, which is an open source MIT licensed library that covers exactly this thing that I was talking about. I'm going to use Remote in this session to demonstrate all of these principles, but you can apply the same concepts to your code with any other libraries or frameworks that you're using. Okay, so what's this live coding session is going to be? We're going to take a React to-do app, really simple one, front end only with no backend. And then we're going to turn it into a full stack app with all of these elements that I've just listed. An Node.js server, end-to-end type safe CRUD API, server-side paging, sorting, and filtering, real-time live queries, validations that you write once and affect both your front end and your back end, integrating a Postgres database, and authentication and authorization. I think I have about 30 minutes to try to do all that. Let's see if I can do it. So this is our React app. Let's see. Pretty simple. It uses Vite for tooling, which I love, and is very fast and efficient. And it has, and that's, first let's start by spinning up this this app. All right, npm run dev, and Vite's going to start my app, and I'm going to open it right here, and you can see the to-dos. And this is all just one single React component. Let's have a look at it. There it is. Let me just close a few things. This is our app component. This is the entire app you're seeing on the right. The task list is defined here as the React state, tasks array. The new task title is this area, what needs to be done. We've got a function to add a new task, which basically creates a new task object based on the new task title, sets some default values, and adds that to the task array, and sets the new task title back to a blank string. We have the set completed function used by this checkbox here that basically creates an updated task and changes that in the array to reflect the new state of the task. Delete task, if I just add one and I delete it using this X, So delete task, just remove the tasks from the array, and set all completed and uncompleted is just traversing the array and changing the state. Very simple React app, front-end only. I'm not sure if I need to even go over the rendering part, but basically we've got a form for the adding the new task. This iterates the tasks and create this list. And here are the set all completed and set all uncompleted buttons. Right. So we've got our front-end only app. Doesn't do anything interesting. Let's move on. Let's create a backend for this app. So I'm going to start by creating a backend folder with an index.ts file. I'm going to use Express. I'm going to use Express on my backend server. Let's define Express app. Perfect. Okay. Now, normally, let's just write one get route just to see that this is all working. It's gonna wait. It's gonna whoa. Careful. Res send I dev days. Perfect. This is our route, and usually we'll have the app.listen here, but I'm not gonna do that. I'm gonna do a nice trick. I'm gonna use vdev server to serve this Express backend. I'm gonna use a plugin. I'll just show you. Import Express from this plugin. Let's see how it works. And basically, I tell it where the source for my backend is, and it's going to use this to run my Express. I'm going to export the app, and this is going to run my Express app with Vite. Let's see if it works. Hopefully, it works. Great. Hi, dev days. So we've got an Express backend running. Vite is going to run it and hot reload it as we make changes to the backend. And let's move on. So let's the first thing I'm going to do is I forgot to mention this task list uses a type for a task. Let's go and look at that type. It's a simple TypeScript class, has an ID, a title, a completed, which is a Boolean, and a created date. So I'm going to use this task class also for my backend. And let's see how I do that. First, let's just move it to a shared folder. Let's create a shared folder. It's going to be shared between the front and the backend. Move that here. Hopefully, everything will still work. Let's go back. Still works. And what I'm going to do is going to expose an API using this task class. Let's see how I'm going to do that. I'm going to decorate this class with decorators from remote. That's the important part. So the first decorator tells this class this is an entity, a business entity, and it's going to have its own database table as well. I'm going to, I have to say that it's allowed, that CRUD is allowed on this entity, and I have to define these fields. So let's do fields. So the ID is going to be a CUID. The title is going to be a string. The completed is going to be a Boolean field. And the created at is going to be a created at field. Perfect. Okay, so I added some code to this task to tell Remote how to expose it as an API. And now all I have to do is go back to my index.ts and import from Remote Express and add that to my Express backend. It's a little bit of work, but here we go. And then I have to expose the entity. So there's an entities array here. I add my task to this entities array, and let's see what happens. So right now I'm supposed to have a API task which returns an empty array. Fine, great, that works. So I already have this API route that returns an empty array of tasks because I don't have any tasks in my backend database. Now let's test this request. This is Thunder client, the kind of like Postman-like thing that I use. Let's post a task into our backend. Let's say its title is test and send. And as you see, the API that we've used to get here, the post is also working, created a task for us on the backend with an ID, a CUID, the title, and the rest of the default values. So also the post is working. So we have that data now in our database. And you're probably asking, where is the database? Because we haven't defined any database. Well, Remount uses a default JSON-based database. It's just stored in this folder called DB. It has a task JSON file, which has our task in it. This is the default behavior. But once we add in a few minutes, we'll add Postgres, and we'll have a decent database. So this is just, it's nice for prototyping, and it's nice for playing around. So now we have, let's go back. We have our setup, and we have our entity, and the API is working. Okay. Now what I'm going to do is I'm going to grab all of these. Let me just hide this. Let's grab all these tasks and just post them into our backend so we have more data in our backend and remove them from here. Once I remove those, the to-do list is going to be empty because I removed it from the React state. And let's just post it here into our backend database. Okay, there you go, some JSON, send. Great. So now we have all these tasks in our backend, and you can also see them in this JSON file. Perfect. Now we have to return these to our front end. Okay, so let's go to our app, and we're going to add a task repo object, which is going to be a repo of type task. This repo object is used by Remount to interact with our backend API and with our backend, and eventually with our database from the front end. It's going to help us create all the CRUD functionality we need for this to-do app. So let's start by fetching the tasks. We're going to use effect from React. And we're going to tell it, like, we're going to say task repo dot find, then set tasks. Once we do that, and once I save it, we're going to get all our tasks back from the backend API. Let me show you the network tab. Okay, again, this is going to run a get request from the REST API we've just exposed using Remount here. By adding the task to the entities array, fetching the data from our backend database and into our React state. Now, this find is very naive, just returns all the tasks. But if we want to, let's say, I don't know, filter it. Let's start by paging it. Let's set a limit to 2. We're only going to see 2 tasks. And let's set the limit to 3. It's only going to return 3 times. This is at the API level. So this is backend paging. Let's go for the second page, page 2. We get the second page, and page 3, we get the third page. So we've got our endpoints, not just returning data, but also performing backend paging for us. Now let's try to filter the data. Let's add a where. And let's say completed, false, or true. Once I do that, all I get back from the API is the completed tasks. And again, a simple REST API get call with a completed parameter. Now, this is also important that this is type safe because, again, we're using the task entity here, which is defined as a Boolean. So TypeScript saves us from doing something like this and throws an error if we try to use a string here. So this is end-to-end CRUD safe. Let's try false. Oh, sorry. False, we get all those that are not completed, and we've shown where. And let's try order by. So we can order by, let's say, create at sending or descending. Again, simple REST API calls, returning data sorted from the backend database, zero boilerplate to get all of this working. Okay, so let's see what we have. Let's order it back like we want to. We've done setup, we've done entities, we've done paging, sorting, and filtering. Let's complete the rest of the CRUD operations so this whole little app is going to work. First, let's do it just one by one. Adding a task is as simple as calling task-repo.insert and sending it the object of this new task. Okay, let's remove unnecessary things because the backend will give us these by default. Sorry, set new tasks. Await, of course. And now when I add a new task, it's going to be added to my backend database. To prove that, I'll go to the backend database and see my test one right here. Perfect. Let's do the rest. Let's do the set completed, which is the checkbox. All I have to do here, again, use the task repo, call await task repo dot save with that same modified object. And oh, I forgot to show that this was the created task was just a post request. Okay, a successful post request with the JSON data, something you would see in probably just any regular REST API. And the same goes for the updating of the completed state. You're going to see a put request, like you see here, with the ID of the task being modified. And once I change it, you can see it kind of live here online. Once I change it, the values, you can see the values changing in my backend pseudo database. Moving on, delete task. You guessed it, it's pretty simple. Task repo. Task repo.delete. Also going to be working. Let's delete one. It's deleting. Perfect. Refresh. Delete it on the back end. And let's wrap this up. And where's the, I want to show the delete action. Let's add one and delete it. You can see the delete request coming in. So we've completed CRUD. But we want to do more because now we have such a nice looking to-do app, but it's very static because it uses only REST endpoints. So if I duplicate it, and let's say I change something here, then the other user does not see that change reflected, obviously, until he or she refreshes the page. And let's change that and change it into something more interactive. So with Remote, it's pretty simple. All I have to do, instead of using task repo find to load the task at the beginning, I'm going to use live query. And instead of that, I'm going to use subscribe, which gets an object that I can use to apply changes to the current React state. That's all I have to do. Once I do that, let's kind of put it side by side, and we can see that the changes are reflected in real time because now it's using server sent events. You can still see the put request because we're still using REST to perform the mutations. But on the other side, all you're going to see is server sent events causing the modification of the React state in this live query. So just changing a single line of code. Again, by using this entity as a single source of truth, this becomes really easy to perform something that would probably require a lot of boilerplate code to do without Remote. So let's see. We've done setup entities, paging, CRUD operations, and live query. Next thing I want to talk about is validation, something I'm very interested in. Because let's say we want, let's go back to our task, which is where again, I would like most of my business logic and validation rules and all my rules to be defined here. So let's try setting this title field to be required. Validators required. Okay, once I do that, if I try to add a task without giving it a title, I'm going to get an error. It should not be empty. But let's look at the network tab. I'm not seeing any network calls being made because this validation happens in the front end. It's not even calling the backend. But if I use the API directly, let's use the API directly. Let me remember. Okay, let's go to API task and try to post an empty task. We're going to get the same error from our backend because the backend is using the task class as well. So it has the validators required in it as well. And this is just a built-in validator. This can be any error function. I can make this, if I just give it a generic type, I can get a task here and say if task title length under 3, throw too short. Wait, just arrange this. Okay, once I do that, I get the too short error here, and I would also get the too short error here. But if I add a task which is long enough, then it's going to work. So the important thing here with validation is you write it once and you get it both in the front end and the back end. And again, it's completely code-based, not some no-code or low-code tool. You can write whatever you want here. You can write logic here that depends on whether it's running on the back end or the front end, different logic, and get very interesting and neat things happening. How am I with time? Fine. Okay, next thing I want to show you is this operation, the set all completed. Okay, let's say I want to use, my user asked me to implement this set all completed, call the backend, set all the tasks as completed or not completed according to the parameter, and let's try to make that work with read. So I'm going to do just iterate the tasks of await task repo find, and I'm gonna task repo update. Task repo update. Task repo save with this task and complete it. Okay. All right. Here we go. So this is going to work. It's updating. All the tasks are being completed. I refresh the backend. It's all reflected in the backend. But let's see what's happening here. There are lots of put requests being made here. So the user is happy. I might be happy, but my boss might not be happy because I'm making too many put requests. And can imagine if there were hundreds of tasks in this list. So this is not a very good idea in terms of performance. But why I'm saying this and why I'm showing you this, because with Remote, I can actually run the same logic as backend code and then call it directly from the front end in a really simple manner. So let's do that. Let's add a tasks controller here. Okay. And in this task controller, I'm going to just copy and paste this code, the set all completed. Okay. I'm going to adjust it a little bit. It's going to be a static function. Okay, it's got to have a task repo. Again, the same way I wrote the front end code, the backend code is going to be the same. It's going to be a repo of task. I don't need this because this is the React code. I've got a static function that does the same thing, and I'm going to use it on the backend. Now, how am I going to tell Remote this is a backend function? I'm going to use a decorator. It's called backend method. I'm going to set its allowed to true. And I'm going to register this tasks controller just like I registered the tasks in my index.ts. So the controllers, task controller. Perfect. And now I'm going to go back to my app.tsx, and I'm going to tell this set all completed function to call directly the task controller, await tasks controller, set all completed. Wait. Set all completed, completed. And remove this. Okay, so I've done a little bit of work, but what I got here now is that once I call the set all completed, I get just one post request to the backend with the completed state which does the work on the backend. And the interesting thing here is that I've used exactly the same code that I was using on the front end to call the database. When I was in the front end, this iteration caused REST API calls. When I'm using this as backend code, it simply calls the database directly. So here it's using the JSON database, and we'll soon have Postgres with SQL statements going to Postgres, but it's going to be the same syntax, doing something different behind the scenes. But look how easy it was to just refactor code from front end to back end. That's the thing I wanted to show you. So let's see what we've covered. CRUD live validation, updating multiple tasks. Let's add a real database. It's time. We've used a nice little JSON database for prototyping, and now we want to move to Postgres. You can imagine this is going to be really, really simple. I'm going to, again, use remote / Postgres. I'm going to import a create Postgres data provider function. And I'm going to set the data provider to that and give it a connection string, which I prepared in advance. Just that quotes. This is my connection string to my Postgres database. And look, all the tasks are gone. They're gone. Why? Because the database is empty. But what you can see is, what you can see in the terminal here is that when I refreshed and when I saved and was reloaded by Vite, Remount went ahead and created a database table called tasks for me. If I look at my Postgres, I can see here, let's refresh, I can see the tasks table was created for me, but it is still empty. Now let's go back to Thunder Client, and hopefully I can find my tasks because, yeah, probably lost all my tasks. Wait, let me get them from somewhere else. No, I lost my tasks. Well, I'll just write them. So we've done a lot of things. We have database. We've just done that. Let me just remove this. And our next thing is going to be auth. We'll do that soon. And the rest will be showing you some examples. So yeah, I lost my list of tasks, but now I have a new one. And we've added a database. You've seen it was just one line of code, a connection string for Postgres, and now this is using Postgres. Let's prove it. Let's go again to Postgres and see if the data is there. If I select the top 1,000, I get the task that I just added. So Postgres is working. Now we're not just using a prototyping JSON database. Take a sip. Okay, last thing I wanted to show is auth, because this is all very nice and not related to the real world, because in the real world, not every user and everyone who has access to my API can just grab all these tasks and do whatever they want. This has to be restricted. So let's say I restrict this and I tell Remote that I want only authenticated users to have any access to this API at all. Once I do that, I get a forbidden error from my from the API that fetches the task. Okay, it's not allowed anymore. I have to do something to change that. So let's go ahead and just I want to say before that, Remote is completely unopinionated when it comes to your auth framework, provider, or any tool you're using to authenticate users. Okay, that's not Remote's concern. We're concerned with CRUD only. But we've used tools like NextAuth or like various tools that Express have, and everything works with Remote, so it's not a problem. Let me just show you a quick example of how I can add auth to this app pretty quickly. Let's go back to the index.js. Now I'm going to cheat a little bit here and use a snippet. Okay, but I'll go over what I've done. Now I'm going to move this. Sorry. Move this up. Where am I? I'm going to move this up. Okay, so I've used cookie session, which is an Express package, which is really naive. session management using cookies. It's pretty simple. You just set it up, you send a secret, and it just works. Okay, so I've added that, and I've added a list of a very, very naive users database. Obviously, in the real world, this is going to be saved in some data store or provider, but these are just Jane and Steve, which are going to be my users for this example. I've added a sign-in route, and you see this is a regular express route, has nothing to do with Remelt. Just goes to show that Remelt is a library you can use with any other way of development you wish. So I have this post for sign-in. All it does is finds the user in the valid users list, adds it to the session, which then adds it to the cookie and sends it back to the front end. A sign out, which basically nullifies the user, and the current user. These are the 3 API routes I added to do this very naive and basic auth solution. On the front end, what I'm going to do is cheat a little more, go to my main TSX for my React app, and change this into a component that I prepared in advance. But it's a really simple one. It just says the name. You write Steve or Jane, and it gets you signed in. It's just to show you what's it's a really simplistic example. Let's say I write Steve. I'm signed in. I still can't see the tasks. Why is that? Because I have not connected and integrated Remote with this whole auth system that I just prepared. So let's go back to my index.ts. Just going to close a few things here. And all I have to do is tell Remote Express here that how do you get the user? To get the user, you get a request object, and you extract the session user from this request. That's it. And I'm back to work, and I see the tasks. So the integration between Remote and a very naive cookie session auth system works with just a single line of code and not a lot of boilerplate. So got this out of the way. I wanted to show you something, just one more thing about auth. It's not just about being authenticated or not. Let's add roles. Let's say that insert is allowed only if you have the admin role, and also delete. Allow API delete only for admins. Okay. So now, if Steve wants to add a task, it's forbidden. Okay, and also deleting a task is also forbidden. And let's say that our user Jane does have the role of admin. Okay, so once we sign out of Steve and sign into Jane, Jane is able to add new tasks. Okay, this is true for the backend API that we've used. So now we have an auth system with roles, which is fun. But what's even more important, and I discussed it a little bit in the beginning, is we have a problem with Steve because Steve is signed in. He can't add new tasks, but he does see this form and also this X button, which he can't use. So let's go to our front end and prevent that. Again, a really simple way. We're going to take this form and we're going to condition it based on our task repo. Again, our single object for everything. Metadata API insert allowed. Okay. So once I do that, Steve can no longer even see the form for inserting new tasks. But if I come in as Jane, I can see it. I can do the same for the delete task. Let's just do it really quickly. Task repo, metadata, API delete, API delete allowed. Right. So now again, Jane can see, sign out, sign in as Steve. Steve can't see the X button. So this is how an auth rule defined at the entity level can affect a single rule defined here. And this can also be arrow function. Okay, I'm just using basic stuff, but it can be arrow functions. You can write whatever you want here. But this both affects the front end and the back end in a single source of truth. That was what I was trying to show you. Let's see how we are with time. We have some more time. Well, first of all, let me go back to the slides, and then maybe I'll show you something else. So this this was the demo. I have a few minor things to show. Maybe I have time and I'll show them. If not, someone will stop me. Remote fits in your stack. I've shown React with an Express backend. We've used it with Angular and Fastify backend. We've used it with various meta frameworks such as Next.js, Nuxt, SvelteKit, Solid Start, you name it. And if we don't support it, open an issue or use our Discord, and we'll just support it really quickly. It also supports nearly every database you can think of. Obviously, the common ones like MySQL and Postgres and SQLite, but also MongoDB, SQL Server, even Oracle, and others. And it can run on any node, bun, or Dino server. There are some features that I wasn't able to show you in this short demo, but obviously you can look and find. Maybe I'll show you the Swagger part if we have a few more minutes. But database migrations, which I don't really like. I like the sync feature I showed you, where you just add an entity and remote checks if that exists in the database, and if not, it adds necessary tables and columns. But you can use migrations like you used to in other ORMs, such as Prisma, GraphQL and OpenAPI, entity lifecycle hooks. Remote is very customizable in the way you can affect everything that's happening, whether it's changing things before the data goes into the database or after, having various hooks and effects, sending emails or text messages or whatever you wish. It's completely supports relations. It's not something you can show in this kind of simplistic demo, but the relational querying part is very impressive. With Remote, you should try it. Things like backend only updatable fields, like things you can't update from the API, but are there. Computed fields, if you don't like decorators, some people don't like them, you can completely use Remote without any decorators at all. You can even use it with plain JS and JSDoc. And this is the Remote website where you can find tutorials and guides on the things that I've just shown you. Now, again, these constructs are something you can use with other frameworks you're using. Just think in this mindset. But if you want to use Remote, it's completely there, free for us, and for you to use. This is our Twitter handle. We do have tutorials for tutorials take you through the entire journey of this to-do app, even further with more features. It's like an hour, and you can be deployed in production with a nice little app written with Remote. If I do have some more time, I think I do. Right. Okay. So I just want to show you one little thing back to the code. Let's show you how easy it is to create a really simple admin UI with Remote. All you do is set admin to true, and we get something like this. Okay, this is just kind of a generic admin with your database, your entities, a nice diagram, which is useless when you have just one entity. You can edit data right here, change it, save. It's nice to have something to, even just for development use. You can really go into, if you have any relations, you'll be able to see relational data here. You can delete and use paging and whatnot. And it just comes out of adding this admin true, and you get this working. If you want, if you like Swagger, let's do a quick demo of Swagger. 3 lines of code. I have to, just one more thing. I have to extract this here into this API variable. And I have Swagger. Let's go. API docs. Here's my Swagger of this API I just created. Here's the GET request for the tasks with all of the possibilities for paging, limiting, and filtering and whatnot, and it just works. So it's really nice. If you like GraphQL, trust me, it's another 2 lines of code and you get a complete GraphQL client working here. All of these are really easy when you use that concept of having an entity as a single source of truth, defining all your rules here. Obviously, like the admin screen I just showed you reflects all those rules. So if I'm signed in with a user who can't delete, the delete will not work, even in the admin. So this is very powerful. Put as much logic, I think, as you can into the business entity and have it affect your entire application. Well, I guess this is what I wanted to show. So thank you. And if you have any questions, I guess that'll be a good time for questions.
Hey, thank you so much, Yoni. You know what? I've been developing all my life with ASP.NET. When I look at this, I think that my next project I need to take remote for a spin. It looks like a lot of fun.
Yeah.
And it was so nice to see you with so much energy going through all this stuff. Um, and just throwing in an admin with one line, throwing in Swagger with a line. It looks
It's
like
fun. It was fun. Yeah, it was
let
fun.
the boilerplate not bother us from doing the stuff that is important, right?
That's right. That's right.
Great. So I'm going to say thank you. I think our time is up. I already see moderator dropping in, and I'm assuming we'll have questions hitting you from different directions later during the conference. So,
Perfect. I'm
Yoni, I'm
here.
going to say thank you.
Thank you so much.
Bye.
Bye.